In this video, we're going to talk about a couple laws of exponents, namely the quotient rule, and that should lead us into a discussion of negative exponents and what it means to be a negative exponent. So to help motivate this discussion, I would like to look at a problem. Let's say we want to do 3 to the 8th divided by 3 to the 6th. And I said, let's do this without a calculator. Well, that's going to be pretty tough, right? 3 times 3 times 3 times 3. That's going to be a big number. So let's go ahead and do it with the calculator. So I'm going to punch in 3 to the 8th. And 3 to the 8th power is 6,561. And then I'm going to punch in 3 to the 6th power. And I get 729. And I could do this by long division, but I've got better things to do with my life. So I'm going to punch this into my calculator, divided by 729, and I end up with 9. Wow, that came out kind of nice. So the question is, how could we do this a little bit smarter, let's say? Well, 3 to the 8th power means 3 times itself 8 times. 5, 6, 7, 8. Multiply all these together. And of course, 3 to the 6th power, oops, I almost crossed out all my 3's. Let's actually make that a little nicer. Divided by 3 times 3 times 3, 6 times. Alright, so if we think about reducing fractions, we know that we can cancel or reduce. 3 divided by 3 is 1, 3 divided by 3 is 1, and so on. And it turns out we can cancel 6 3's on the top and 6 3's on the bottom. And what are we left with? We're left with 3 times 3. And for the sake of motivating this rule, that's 3 squared, right? Which is 9. Right, so that's a lot faster way to get to the answer than using our calculator to figure this out. So notice I had 6 3's and 8 3's, and I ended up canceling out 6 3's. So what's a little shortcut here? 3 to the 8th divided by 3 to the 6th turns out to be 3 to the 2nd. We canceled out 6 of the 3's, canceled 6 of these with 6 of these, and we were left with 2. So really, if we just subtracted the exponents, 3 to the 8 minus 6, we would end up with 3 squared and get 9. And that is the quotient rule. All right, so we can use this rule. Let's write it out. Let's say I have x to the a over x to the b. I end up with x to the a minus b. All right, that's a quotient rule. And of course, you can use this with variables as well. So if you have y to the 10th power divided by y to the 3rd power, then you want to reduce that fraction. You could write out all the y's, and maybe if you forget the rule, you could, it doesn't hurt to write them all out. But the rule here simply says that's going to end up being y to the 10 minus 3. And why is it minus? Because you're canceling out that many y's. You're going to cancel out 3 y's, and that's going to leave you with 7 y's multiplied together, which is y to the 7th. All right, so just to make sure we're getting that, 6, 7, 8, 9, 10, those are all the y's multiplied together. Y to the 3rd on the bottom. All right, cancel, cancel, cancel. You cancel out 3 y's in the top, in the numerator, and 3 in the denominator, and you're left with y multiplied by itself 7 times, which is y to the 7th power. All right, so pretty cool little rule. Hopefully you remember also the product rule, and I covered that in a different video, but let me write it over here. So this kind of goes along with the product rule. Remember, x to the a times x to the b is x to the a plus b. That's the product rule. Right? So if you're multiplying with a similar base, same base, and different exponents, you add the exponents. If you're dividing with the same base, you subtract the exponents. All right, so let's do one more. We could do something like, well, we're going to do more than one, but before we get to negative exponents, let's say I had 3x to the 10th, y to the 7th, all over 6 x to the 5th y, just y. Let's do that. All right, and I'm supposed to simplify this fraction. Well, the 3 and the 6 are just like 3/6, just like it's always been. So you would reduce that to 1/2. Okay, just their coefficients, you're going to treat them like you always have. Next thing we're going to look at is this part. Now, don't be tempted. A lot of students want to do 10 divided by 5 and get 2. But these are exponents now, right? So what do we do with the exponents? We subtract them. So it's going to be x to the 10 minus 5, which is x to the 5th, and that's going to go up here. Okay, and y to the 7th. You could, I'll show you how to write this without a whole fraction, but you could write it separately if you want. I'll show you in a minute here. So y to the 7th divided by y. Well, there's no exponent here, right? So what does that mean? That means y to the 1st. So 7, take away 1, because you're going to basically cancel one of these y's. You're going to end up with y to the 6th. So you can write it as one big fraction like I've got here, x to the 5th, y to the 6th, all over 2. Or if you prefer, you could put the 1/2. 3 divided by 6 is 1/2. And then times x to the 5th, y to the 6th. All right, these two things are equivalent. They're the same thing. Either way would be correct. So hopefully you're asking yourself, well, what if the top number is smaller than the bottom? In other words, the exponent in the numerator is smaller than the exponent in the denominator. Like, let's say I have something x to the 7th divided by x to the 9th. If I follow this rule exactly, that's going to be x to the 7 minus 9, which is x to the negative 2. I don't know what a negative exponent is, okay, so we need to think about that. Well, I also know if I were to write this out and then cancel, I should make these exponents smaller, huh? 3, 4, 5, 6, 7, 8, 9, and I cancel these out, I would end up canceling 7 of these x's, right? And what would I be left with? Well, in the numerator, I don't have anything left. Remember, x divided by x is 1, so technically there's 1 on all these. I'm multiplying all these 1's together. I'm going to end up with 1 in the numerator, and in the denominator, I end up with x to the 2nd. So if I follow my rule, I end up with x to the negative 2. If I cancel them all out, I end up with 1 over x squared. Guess what? These two things are equivalent. That's what negative exponents mean. So our rule for negative exponents says x to the negative n equals 1 over x to the n. Actually, maybe I should use a. Since I've been using a's and b's for my exponents, I'll be consistent. Although some books use n, it really doesn't matter. I'll just try to be consistent here. There we go. Now this is a really tough one for students when they first learn it. A negative exponent means to do the reciprocal. It's not a negative number. Let's look at an example with numbers instead of x's. And then maybe we'll pull up the calculator. A lot of times students are convinced by the calculator. I'm going to use smaller exponents this time. Let's say I have 2 to the 3rd divided by 2 to the 5th. Okay, this is a good example. So if I use my rule, I have 2 to the 3 minus 5, which is 2 to the negative 2. Now by this rule down here, 2 to the negative 2 means 1 over 2 squared, which is 1/4, 1 over 4. Okay, to convince you that's correct, let's say I did 2 to the 3rd, that's 2 times 2 times 2, and then 2 to the 5th. I could cancel these 2's. 2 divided by 2 is 1, 2 divided by 2 is 1, 1 times 1 times 1 is 1, so I have 1 left on the top and 4 left on the bottom. Another way to maybe convince you would be 2 times 2 times 2 is 8. And 2 times 2 times 2 is 8, times 2 is 16, times 2 is 32. And certainly 8 over 32 reduces to 1/4. So that is our answer. So a negative exponent means a reciprocal, okay? Another thing that you can do with this quotient rule, let me make a modification of the quotient rule. I could also do, let's say B is bigger than A, and I have x to the A over x to the B, okay? And in this case, this exponent B is larger than this exponent A. Then instead of doing A minus B, I could do 1 over x to the B minus A. Okay, so that's another way you could approach these, and that's what's tricky about these problems too, is there's more than one way to do them. There's multiple ways to get to the right answer. So for example, over here, if we look at this 2 to the third over 2 to the fifth, what we did was we did 3 minus 5 and got negative 2, and then used the negative exponent rule to bring the 2 to the negative 2 in the denominator and make it positive. But if we use this modified version here of the quotient rule, since 5 is bigger than 3, I'm going to subtract the 3 from the 5, and since the 5 is bigger than the 3, then my answer needs to go in the denominator where my largest exponent was. So I could think of it like this. Okay? And then that would give me 1 over 2 squared, which also brings me to 1/4. Okay, so you could go this route or this route. Me, I prefer to keep the exponents positive if I can. Okay, sometimes you're going to be given a problem where there's already a negative exponent in the problem, and I'll show you some of those. And then you're kind of stuck. You have to deal with the negative exponents. But a lot of times you can avoid dealing with the negative exponents. Let me show you an example. Let's say we've got 10 x to the 8th y to the 10th all over, let's do 15 x to the 11th y to the, how about third? Okay, and I want to reduce this fraction. So what I usually do is I just put a fraction bar here and I start reducing it one piece at a time. The first thing I'm going to reduce are the coefficients. 10/15, I'm just going to reduce that like normal. 10/15 reduces to 2/3. So the 2's in the numerator, the 3's in the denominator. Next thing I'm going to reduce is this, the x's. Alright, so 11 is bigger than 8. So I'm still going to subtract these exponents, but I really have this case down here, right, where the b is bigger than the a. So I'm going to do b minus a, 11 minus 8, that's 3. And where's that going to go? I'm going to have x to the third. Is it going to live in the numerator or the denominator? Well, it's going to live in the denominator, right, because I had more x's in the denominator. And if you think about writing all these out, you'd have 11 x's in the denominator and 8 in the numerator. And then you would cancel them, and you'd be left with the 3 x's, but they would be in the denominator because you started with more in the denominator. Now, how about y to the 10th over y to the third? Right? If we wrote all these out, we'd end up canceling out 3 of these y's with 3 of these y's, so we'd be left with 7. And we could get that by doing 10 take away 3, and we would have more, the y's that we would have left would be in the numerator. So our answer is 2y to the 7th over 3x to the third. All right, and that's the quotient rule. So the big thing with the quotient rule is to subtract the exponents, subtract the smaller one from the bigger one, and then put the answer wherever the bigger exponent resided. All right, if the bigger exponent resided in the denominator, put what you have for your x's in the denominator. In the case of the y's, the larger exponent was in the numerator, so I'm going to have y to the 7th in the numerator. Okay, let's look at some more difficult examples that have negative exponents in them. So let's say you ended up with something like, well, first of all, let's do, if you had, say, 5 to the negative 2, and you were supposed to figure out what that was. Okay, if you punch this into your calculator, if you punch in 5 to the negative 2, it's going to say 0.04, or if you put that into a fraction, it's 1 over 25 if your calculator does fractions. So basically, 5 to the second is 25. 5 to the negative 2 is the reciprocal of 5 to the 2. So when you see a negative exponent, you need to think about reciprocal. It's the reciprocal. So if I have, and this is really where students get a little bit crazy here, if I have 1 over 5 to the negative 2, what if the negative's already in the denominator? All right, how do I do the reciprocal of it? When you do the reciprocal of something, you basically switch the numerator and the denominator, okay? So what this rule says with negative exponents, right here, let's see, why isn't that coloring? It doesn't like it. Oh, let's try black. Okay, now it's working. What this rule says right here is if you have a negative exponent and you want to get rid of it, you have to take the reciprocal of it, all right? You move it to the bottom. This is generally the only rule that books will have with negative exponents, but I could write a modification of that rule if I had 1 over x to the negative a. The reciprocal of that would be x to the a. Okay, so when you do the reciprocal, then you change the exponent from a negative to a positive. So if the exponent is negative and it's in the numerator, so to speak, right? If it's a whole number, it's like over 1, then you would move that to the denominator and make it positive. If it's negative and it's already in the denominator, you would move it to the numerator. Now, I know some of you are saying that's not a numerator, there's no fraction there. But remember, this is always thought of as over 1. Right? If you have a whole number, x to the a, you could think of that as over 1. So it's in the numerator of the fraction, even though there's not a whole fraction written. So if I have 1 over 5 to the negative 2, that's the same as, I want to get rid of that negative, so I'm going to move that to the numerator, and then I can get rid of the negative. And if you want to write the over 1, that's fine, because I'm saying numerator, and I'm not writing a fraction, but hopefully you're with me on that. And 5 squared is 25. Okay, so you always want to get rid of negative exponents whenever you see them. And the way you get rid of them is to move whatever is to that negative exponent either from the numerator to the denominator or vice versa. You do the reciprocal. So here's a typical problem that a book will give you that will make you crazy. All right, x to the negative third. Let's see, x to the negative third, y to the negative fourth over x squared y to the negative 7. Okay, so what do I have that's to a negative exponent? I have this that's to a negative exponent. So to get rid of that negative exponent, I'm going to move this guy down here, and it's going to become x to the third. All right, and then that's going to be gone. So when I move it, the exponent becomes positive. I have this thing that's to a negative exponent. So I'm going to move it up here, and it's going to become y to the positive 7th, and that's going to be gone. And this guy is to a negative exponent, so I'm going to move it down here, and it's going to become y to the 4th, and that's going to be gone. This x squared is already a positive exponent, so I'm not going to move that one. All right, what do I have left in the numerator? I have y to the 7th left in the numerator. In the denominator, I've got x to the third, x to the second, and a y to the 4th. Now I can simplify this. It's all positive exponents, so it's going to be a little easier to simplify. With the x to the third times x squared, I'm going to use my product rule, and I'm going to add those exponents. And those x's are in the denominator right now, so they need to stay there. Okay? They need to stay down there. With my y's, I have y to the 7th divided by y to the 4th. I kind of crossed that out. Let's try that again. Y to the 7th divided by y to the 4th. That's my quotient rule, so I'm going to subtract those exponents. 7 take away 4 is 3, and the 7's in the numerator. That's the larger exponent. So I am going to write my answer in the numerator, and that is the simplified answer. Kind of crazy, huh? It just takes some work with these rules to get used to it. Now let me show you another way to do this problem. Like I said, part of the issue with this is that there's so many ways to do it. Students can get a little overwhelmed, but as long as you're using one of these rules, you're safe. Okay, so we could have just used the quotient rule from the start with the negatives. Okay, so let's say I do, I'm just going to do the top minus the bottom. Okay, so with the x's, I have x to something over x to something else. So I could use this quotient rule right here and do negative 3 minus 2. And then y to the negative 4 minus negative 7. Let's see what we get. So I have x to the negative 5, y, and then negative 4 plus 7, minus a negative makes a plus, makes 3. Let me get rid of this here since it's kind of in the way. All right, now generally the instructions will always say to write your answer with positive exponents. You still need to get rid of the negative exponents, and I have this guy right here which has a negative exponent. And I don't want a negative exponent for that. So what I need to do is make a fraction. And then I'm going to move this guy to the bottom of the fraction. And it's going to become positive. And then that's going to go away. So I'm left with a final answer of y to the third over x to the fifth. Notice that is the same answer that we got when we used a different method. Okay? It just depends which rule you want to use and which order that you want to use it. And that's the key, is to have these rules memorized and know how to use them. And every step you take, you got to ask yourself, am I using one of these rules correctly? Okay, let me show you one more thing, one more quick thing with negative exponents that you might run into that's kind of tricky. If you have a whole entire fraction to a negative exponent, like let's say you have 2/3 to the whole thing to the negative 2. Remember, negative exponent means reciprocal. Negative exponent means to take the reciprocal. This is worth writing down and highlighting and telling yourself a whole bunch of times. Negative, okay, I can do this. Negative exponents mean reciprocal. Okay, they do not mean negative numbers. They mean to take the reciprocal. So when I get an exponent of a negative 2, right here, this is telling me to do two things. The 2 is telling me to square it, and the negative is telling me to do the reciprocal. Okay, so I need to square the reciprocal of 2/3. What I like to do is first do the reciprocal. So there's my reciprocal, and then square it. Okay, so if you have a fraction already, just flip it over, and then that gets rid of the negative in the exponent, and then you can square both the numerator and the denominator, and you have your answer. All right, and you do the same thing with x's. Say say you had x over 3 to the negative 4th, and you wanted to simplify that. Flip it over because of the negative, and then just take it to the 4th. So that's going to be 81 over x to the 4th. All right, and there's also the power rule, which I covered in another video, and all these rules can get combined together to do multi-step problems. Memorize these rules, practice them, ask yourself if you're using what rule you're using every time you take a step, and you should be good to go.